I'm going to present to you Search the Docs, ElasticSearch at Read the Docs from Santos Gallegos. Santos, I'm going to now pass control over to you.
Okay. Hi, everyone. Well, my name is Santos Gallegos. I work at Redux. I am a Python developer. I do mostly web stuff. And you can find me on the internet like STSEWD. Now, for those who don't know, we're going to talk a little about what Redux is. Redux is a platform that allows you to build and host your documentation. It was created around 2010 by Eric Holzer and others. We host more than 100,000 open source projects, including like projects like Flask, pip, docs, requests. So if you are a Python developer, your probably chances are that you already read docs hosted by Redux. And maybe it's easy to recognize by this little selector here that you can always see to the top bottom right of the pages. Some features that Redux offers you are like versioning, translations, subprojects, and server-side search. And that's what I want to talk to you about today. Let's see this full screen. Yeah. So server-side search. We aim to provide better search experience inside and outside docs pages for Sphinx and Enki docs. Enki docs is partially supported. It doesn't mean it doesn't work. It works. It's just we're still testing. So if you have Enki docs project, you want to test our server-side or our server-side search, please let us know. We also allow things like ranking and ignoring pages. This means that you can give priority to some pages over others, or even ignore them. This is like tweaking your own search engine. You can also use server-side search from outside Redux. This is done using our API. And also we support things like this simple query string syntax that is from ElasticSearch. You can do like an exact match with double quotes, like a prefix search or even a fuzzy search with the tilde operator. Before we go to the fun part, let's see a little about the history of Search Redux. It was added in 2013 by Rob Hodgson. At this time, the team was very small, maybe 2 people at the time. We are still small. We are 5 people now. And search was working, so why touch it? And it was like that till 2018. Yeah, that's 5 years. Where Safwan Rahman, he participated as a Google Summer of Code student. He helped us to migrate Elasticsearch from 1.3, which was already end of life in 2016. He helped us to migrate to the version 6.x. Also added some features like the simple query string syntax, improved the results order, and added some management commands to allow us to index with 0 downtime. And actually, I joined the team around that time. And 2019, Vaibhav Gupta, another Google Summer of Code student, he helped us with creating this search API extension. We'll see a little later what is that. And also help us with adding search analytics. He also helped us with the migration to 7.x. And 2020, 2021, guess who? Me. I've been focusing more on search during this time, and also added another stable API, improved the HTML parsing, added support for empty docs, and added the options for ranking and ignoring pages. Okay, now let's go to the fun part. The indexing process is explain how this is about. We start with parsing the configuration file. This is the Redux configuration file, which has information how to build your documentation and also has options about search. Then we have the Sphinx build process, which generates the HTML pages. And we actually here hook a custom extension that allows us to dump some metadata about each page, like a title and some HTML content. And after that, we start tracking each file and giving them their ranking option, and if the page was ignored or wasn't. And in a later step, we go over again over each HTML file and retrieve this JSON metadata file from this previous step. And we start to parse the HTML content to make a searchable text. And this is going to lead to ElasticSearch for indexed. For mkdocs, we have something similar process. Actually, we don't have an extension like we do with Sphinx. Instead, we use the HTML itself from the pages to index it. Now, we're going to see a little more about this, hopefully in a couple of minutes. Well, we started with the configuration file. This is how a Redux configuration file looks like. As you can see the version where the Sphinx configuration file is, the Python version you're using, the requirements, and here we have the search options, which we are going to focus today. So if you can see, here we have the ranking option, which is a mapping of some pattern files to a number. This number can go from -10 to 10. This is 0 included, but 0 doesn't mean like to ignore the page. It means like normal ranking. All pages start with the ranking of 0. And if you give it a lower ranking, or you can give it a greater ranking. And we also have the ignore option. This is a list of file patterns that you don't want to show these results in search. Now, let's see how we do the indexing the content itself. So we say we get this metadata file from Sphinx, or in the case of mkdocs, we actually get the file itself. We extract some searchable content based on some heuristics. These heuristics include things like expecting the ARIA roles, the ones you use for accessibility, or the HTML tags itself, like because semantic web. Based on that, we identify like the main node, the node that has all the content we want to index, and that we remove some content we don't want to index, like navigation nodes or like line numbers from code blocks, since we don't want to index. And finally, we divide the content into sections and domains. Sections are like a page has several sections. They contain a title and a content. And in Sphinx, we have things that we call domains. Domains are like the documentation that we extract code. So we have in Sphinx, we have like a Python domain or JavaScript domain, and those domains allow us to point to the source code. There you can see some links to the code if you are interested in how that works. But let's see this in a little more visual way. Here you can see how we identify the main node. Here, for example, we are using the ARIA role main to identify the content. So we don't index things like the footer, like the navigation, navbar, sidebar. And here we are removing nodes. Here, for example, we can use like all roles that have navigation name, or all roles or tags that have the nav tag. We remove those. We don't want to index those content. Another example of removing content is like these adornments, like these scenes that we see to the side of each title. We don't want to index those, so we remove those as well. Here is example of how we identify sections. If I say a section has a title, it has some content, we can have sections followed by each other. We can see here. We can also have another case is having nested sections. So we actually, in our parsing process, we identify each section. Okay, that's how the index process is. Now, for ignoring pages, it's easy. We don't index those pages. We just ignore them. For ranking pages, ranking can be done at index or search time. So they have the pros and cons. Like you can have like faster queries when you do the index at search time. Sorry, to index time. But you will need to reindex everything when the ranking change. So for that reason, that was the case. We went for doing a search time ranking. And we do that with this function score query, which is actually is using this script score attribute from the query. And what we put in here is script, and that script is called in this painless script language we have. We use that painless script to map each ranking that goes from -10 to 10 to an ElasticSearch score. So, but when we do this mapping, we need to be careful because we don't want to be like the ranking take over the results. We want to play nice with the custom boosting so users can still see relevant content. It doesn't matter the ranking that the page has. If the search matches something relevant, we show that to the users. Okay, let's see that with some examples. Here we have a configuration file. Actually, this one is one that we use at Redux. Here, for example, we are ignoring some pages. What we ignore here is, for example, this internal documentation. This is some design documents we use, like when we implement a new feature, we write how we are going to implement it and other stuff. So it's not something we want the users to find. And obviously the search page, the 404 page, we don't want the users to find that either. And the ranking option. For ranking, we are using it, for example, for deprecating content. Like we have API v1 that is deprecated, so we don't want to show those results to the top. So we give them a ranking of -1. Also for the configuration file, this is deprecated. And another use case is like content, content we want the still users to find, but it's not something relevant, like the change log. Okay, this is better explained with some examples. Like you see this image. Here you can see to the left, we are using the custom search options, and to the right, we are not using those custom search options. So you can see the first result when we search for pull request is a design document for pull request builder. So this is how it is implemented. So we don't want users to find that. What we instead want is users to find how to use it. So as you can see, this result isn't present at all here, since the page was ignored. Let me see another example. Here is like we say here, changelog, we gave it a ranking of -6. Here to the left is using our custom search options. To the right is not using the search options. So you can see changelog is still there. You can see still in the results, but is down the list. So giving a lower ranking doesn't mean that it's going to disappear, still be there, but it isn't going to be to the top of the list. And here we have example when we use the rank of -1. Here, for example, we search for build image. To the left again is we are using the custom search options, and to the right we are not using them. And here we can see we see the first result is from the version 2 of the configuration file, and here is from the version 1, which is deprecated. But when we're using the ranking options, we see that the result is now the second result is now from the V1, but the first result is from the V2, which we want users to find first. So that's a great way of duplicating content. And this is we saw for ranking pages at search time, we use the painless script. This is how the painless script looks like. It's almost like Java. So if you aren't familiar with Java, or you haven't coded in Java in a long time like myself, it may not be that painless to code it. Here we map each ranking that goes from -10 to 10. Those are 21 values. We map each of them to this array of values that go from 0.01 to 2. Here we multiply our custom score, that is one of these numbers, from the original score, which is in this variable underscore score. So you can see the middle number is 1. So that's what it means to be a ranking of 0. It's multiplied by 1, it's the same value. And if you multiply it by a number less than 1, the ranking score decreases. Or we multiply it by a number that's greater than 1, the score increases. And these numbers here, 0.8 and 1.3, are actually like magic numbers for say. This is because these numbers were calculated our based our boosting values. So these were the numbers that we find that play nice with our boosting values and still give relevant results for the users. But as we say, we are using this to be able to change the score without having to reindex. So if you just see that doesn't work for you, or if you want maybe a greater number here, we can still change that, and we don't need to reindex the whole projects for that to take effect. And overriding the default search. So we provide server-side search inside the docs pages. This is done by overriding the default search. We do that by hijacking the search code via JavaScript, but we keep all reference to the original search. This is in case of backup. Like what happens if the API is down, or if we don't return results, we call to the original search. So, in case we miss something, you still get results. And for this reason, if you ignore some pages, you may still see them in the results, but you will only see them if we call the backup search. So, it's not, I don't think that's a big deal. Okay. Here is in code how this looks like. This is more or less a general example of how we do that. We keep a reference to the original search. We call our API. And if we don't have results, we call to the original search. Or in case the API fails, we still call to the original search, so you get results. And we inject the results there. This is how we do for Sphinx, but for mkdocs is something similar to this. And our API is actually built with Django REST framework. It's a wrapper around the Elasticsearch response, but we use serializers before passing that response to Django REST framework, and actually supports pagination and other stuff. We used to return the same response from Elasticsearch, but that wasn't a good idea because every time we will upgrade Elasticsearch, the response will change and our API will change. We don't want that. So with the serializers, it's not going to break. So as we can see, it's just a normal Django REST framework API. We can even have pagination. Let's see. There you go. If you want to learn more about that, there is a link to the source code there. There is also the documentation. So you know what it means, each field of the response. Okay, hopefully that was okay. Our problems. Let's see some problems that we have and solutions, of course. Latency. So for our API response was very slow, and some things we noticed was our Redux application was on Azure, and our Elastic Search Cloud instance was in AWS. So what we did to improve latency was to move the ElasticSearch Cloud instance to Azure. So latency improved there. For our commercial solution, we have like a similar problem there, but actually there were Elastic Cloud was hosted on AWS, and our application is on AWS as well. But the difference was the zone. They were on different zones. So we migrate our Elasticsearch instance to the same zone, and the latency improved. So in conclusion, make sure Elasticsearch deploy is on the same cloud provider and zone to improve the latency. Partial turn results. So we host technical documentation, so users actually search for code and words. And what I mean by partial turn results, because we wanted to improve this, here is an example. For example, if you search for thing, you may also want to find things. Or what about if you make a typo, without the H? Okay, you can use something like a diffuse operator here, but you made a typo, you don't know if you made a typo. Another examples we have is explicit suffix search. This is supported by the simple query string query of Elasticsearch. But we also may want to do something like like explicit suffix search. This isn't supported by the simple query string query. Another we may want to implicitly way do a suffix search like test. You want to search maybe for testing too, or maybe both. You search for index, you may want to find reindex, indexing, or reindexing. Okay, so as we saw, we have simple query string query, which allow us to use uh, the fancy syntax, like quoting a term, having the tilde for fuzzy. But we also have like this multi-match query, which allow us to set some fuzziness level on the queries. We also have this wildcard query, which allow us to have like prefix and suffix search. And we can combine them multiple types of queries in one. But there is a problem that we don't always want to combine them all because they may be slow or because they may not be having like relevant results. So in order to improve that, we separate each search into some categories, like a single term, like a single word is going to be like a wildcard query, and also using some fuzziness level. But in case we have like a simple term search, is a query that doesn't have the syntax from the simple query string query. Okay, so in that case, we use this type of query. And complex terms are the ones queries that have the syntax from the simple query string query. So what we do here to detect this is pretty simple. Like if we see that there is a quote or there is a tilde in the search term, we say, okay, that have the syntax from the query simple string query. So we use that query. It's really, it will depend of this because it's not like very common to have like a normal query with quotes. So that's fine. Okay, but something that we just read the documentation about the wildcard query. You'll see there is a note there that it says that it may be slow if you use it over text fields. And we say, okay, maybe they aren't that bad, and let's try it. We try it in production, the server died. Yeah, it was throwing 502 errors. It was slow. Luckily, we put that under a feature flag, so we were able to roll it back immediately. So nobody saw the errors. Good news is that we have another type of field that is called Wildcard Field, where wildcard queries or wildcard fields are fast. But now we have to decide what we use. We use wildcard or we use a text field. And each field, they index the content in a different way. So they are in like, we were going to use like the simple query string or a wildcard or text field. It's going to be the same results. No. So luckily, we can actually use both fields. This is called multi-fields in Elasticsearch. You can actually index the same field in multiple ways. I actually have an open PR about that. Anyway, we tested this. We haven't tested this in production. That's why the PR is open still. But hopefully we can test it and it's going to be fast. We actually tested in our commercial solution where we have the number of projects is very small. So the index is very small. So we didn't notice much like very slow queries there. Okay, other things I didn't talk about here, or maybe I didn't mention it, is like we use a sponsored account of Elastic Cloud for our community site. Thank you very much, Elastic. We actually cache the results via Cloudflare also. So in case you or anyone else search for the same term, you probably get a cache response. And the content is static, so caching is fine. But we also push the cache when a build happens, so you won't get outdated results. And the search type extension, let's see, what is this about? So this extension provides this nice modal window here where you just type and the search results are there. There's nothing here. Configuration probably. So now you don't have to move to the. This is the search page of Sphinx, the default one. We provide this nice model, so you don't have to. You go to this page to search something. Okay, and now what's next? Obviously, we will need to improve the results for partial terms with this peer that was already open. We're also trying to consider using the number of page views into results. This is obviously also done with the dependency script. We're also taking care of so this the page views still give us relevant results. So they play nice with the ranking options and with the boosting options. Use server-side search by default for mkdocs projects. Like I say, this is still experimental, but it works. Actually, let me see. I have some examples here of mkdocs. Let's see if I can get in here. Okay. Oops. Okay, here we have the default mkdocs project. Let's search for something here. Thing. This is the default search, and this is using our server-side search. Let's see. Oops. So one thing you can notice is probably the highlight. So you can actually see where your terrain is matching. And another thing is we group results for page. Like we have this, you have this styling your docs page, which has this subsection that contains a match. You have this custom themes page, which has these sections. And here you only have like sections of pages, I think. I think they are sections, yeah. Anyways, you can see, well, this is the mkdocs integration is working. So if you have a project, you want to test it, let us know. Okay, where we go? Okay, and this one are a little gray because they are still pending a design decision, or maybe these are just ideas. So they may be not implemented like soon, or maybe never. We're trying to enable search indexing for pull request previews. We don't do that now because we want to keep the index small, but maybe we can, maybe you could enable this by indexing using another index. Another feature nice will be probably ignore a ranking per sections, because right now it is per page. Better results, better display for results from code blocks. What I mean by this, let me show you image. This is just a really proof of concept I did. So instead of seeing the these results from code blocks in a linear way. Like here you can see this line, you get this nice code block instead. Maybe search for image and code snippets, because it's easier to remember an image or a code snippet than the paragraph itself. So we could have something like this. Search by file patterns and other facets. This is like, what if you want to search only for things inside a directory? Like I only want to search things inside the API directory. So that will be possible with that. And okay, that was everything that I was able to tell you about ElasticSearch at Redux. Hopefully it was interesting. You have any questions, please don't doubt to ask. Doesn't matter the question. You can actually see the code for this talk there. Hey, Jay.
Hey, no, that was awesome. I did have a few questions that I saw in chat. I think most of them got answered. If I don't mention it, then feel free to ask it again. Actually, we do see one hand raised. Vinod, if you want to either enter your question in the chat, or I don't think you're muted. There you go. You should be able to unmute now and you can ask your question if talking is easier.
Yep, talking is easier. Thank you. Hold up. I can't turn my video on, I guess. It's fine. Question. New question. What's the scale of the entire cluster? And what are the plans for scaling more?
Sorry, could you repeat the question?
What's the scale of your cluster for search?
That may be, I'm not sure.
Confidential?
Well, it might be confidential, but he also may not have access to that part of the knowledge if you're working from the code level side. I know that's often
gotcha.
like the separation of concerns. Sometimes the developers don't know how big the service is. They just need to make sure that their code can scale to fit it.
Gotcha. Yeah, it's an infra question. Sorry. So specific to development, did you guys identify any bugs in things like concurrency and such for either relevance or ranking? And was there any contribution back to Elastic's master branch?
No, we haven't contributed back. It's mostly we are only using the Elastic client from Python. So actually, I saw there is this forgot the name. Let's check back here. Okay, the Wildcard Fields. They're wearing in the Elastic client when the last time I checked. So I was trying to like maybe contribute back in the future, but there was still an open PR about that. So maybe there is already Whitecar Fields there. I don't know.
Luckily, I know the people that work on that, so I'll make sure to ask that for them.
That was easy. That's all. Thank you.
Were there other questions? If not, I have a few to keep the conversation going. We still have about 30 minutes or so, and if not, we can always let people leave early. That's always fun. The first question that I had was, you mentioned using painless in conjunction with your Python results. Did you have any problems integrating both painless, which like you mentioned is very Java focused, and the Python side? Because I tend to have that problem where it's like I have to get all of my queries done right, and then I try to add painless to the end, which turns out to kind of be somewhat painful at times, but it's often user error, not code error.
Well, actually, what I did was like client test things out till they work, because I didn't find a easy way to debug things there. Like I was trying to hard code values to see if they're actually doing something. Let's see what it was. So actually, I learned to code with Java in school, so it was kind of a little familiar. Having coded Java in a long time, but it's still small. Our parents script. This is actually what is used in production today, but when adding the page views, is getting a little bigger.
I was gonna ask. You mentioned using page views. Are you using the Elastic Stack for that, or is that coming in from like an analytics tool and being kind of fed into it? And there's no wrong answer here. It's not a loaded question.
That's fine. No, we're using page views. We actually store that from our application. So we have the data in our database, and we feed that into the payments script to calculate the score.
So it should be pretty easy to add, right? You just one simple PR, and we'll all petition Eric to get that pushed through. All right, so that's the first question. The second one that I had was, you mentioned using the search, using wildcard search, and also searching over wildcards in text fields, and you wanted to add the ability to do both. You mentioned that it is working in the commercial side where you're testing it, but have you seen much of a change in results by doing that?
Yeah, actually we did that because we wanted to improve like this type of search. So people wanting to see like search from code, like what if everything that ends with something, period, point, something, or we're searching for a class or an API. You only know the start of the word, so you want to like a wildcard search in that. So we actually starting adding that because to solve that problem. And yeah, it works. Gives nice results. Actually have let me see. I have can show you. Put this here. Okay, this is the documentation of Redux, but this is actually hosted on the commercial side, and I have enabled the feature here. Okay, so here, for example, I'm going to search theme, and well, we actually, I think that's a race condition there. Okay, so okay, that isn't working. I think there is a race condition around that. Yeah, it disappears. Well, anyway, hopefully you see this the first results. They include both they include results from theme and looking for things. They even include this and other things. But this is only using the wildcard search over the text field. This is currently using that. We haven't deployed the other PR that I have open, where we are going to use the multi fields. But locally, I saw there were like better results using multi fields. Like you don't get things like this in other in all those searches, like in the first results.
That makes a lot of sense. And that was kind of answering the question of like, what is the difference when you say, okay, we're just going to search over wildcard, or we're just going to do single simple search terms. And then, the idea of trying to do both and figuring out how that process works. Yeah, I don't want to have to worry about that either. And then you mentioned adding the weight by page views. That you said that is going to be just included into the painless script from there.
Yeah, it's going to be included in the painless script. That actually, let's take a look. Oops. Okay, so as we saw, the another painless script was really small, and this is the painless script with page views added.
That's a lot
It's
larger.
still small. Yeah, it's mostly like null checks and all that. Maybe there is a better way. I don't know.
Yeah, it's always interesting to see, like, let's do it by one. That's easy. Okay, now let's add another thing. Well, that's not so easy. I like that. That's funny. And then one last question. This is kind of a question that Vinod had earlier that I kind of want to modify a little bit. I think Vinod asked originally, what are the index templates like? And I'm assuming that it's pretty simple. And the reasoning for that is you're building search for multiple sites that have simple needs and not so simple needs. How much configuration do you give to the users of Read the Docs? Like, I know you showed us, the ignore, and you showed us the ranking, but are there other controls that they can modify based on their config?
Now, currently, actually, the ignoring ranking options are kind of new, like was implemented like last year. So actually, we are trying to give more control to users right now. Then I don't know. I don't think there is another things users can modify. But we're open to add more options if that makes sense. Like maybe users don't want server side enabled. We allow them to disable them. Actually, we do that. But yeah, I mean, ranking and maybe page views is something is merged. It's probably that's going to be an option. The users can opt in.
I like it. So at this time, we're gonna last call for any questions. Also, just a simple reminder, somewhere buried in the chat. Let me make sure we add. Oh, you have another one, Vinod. Go ahead and ask your question while I'm finding links.
Yeah, I'm going to try to imbibe some wisdom here. How are you guys? Are you all profiling the search improvements across version, right? Like, let's say you implement a change for a search, iterate on it, kind of improve, maybe painless, maybe not, right? How are you going about testing the improvement? I would assume you're hitting the search profiler, right? And like look at, okay, which shards the search is hitting at a shard level. Are we seeing improvements? And maybe tweaking dials and knobs, like, I don't know, a lot, right? Caches at various levels and whatnot. But TLDR, any tips there?
Well, actually, like the latency improvement that we saw was actually from I don't remember this tool. Like let me check real quick.
I think on the Make Docs demo, like there was a a visual latency improvement. That was kind of interesting that you could see it real time, like the difference in not just the feature set, but also in the response time.
Nice. Yeah, I like visuals.
Yeah, well, it was, well, obviously, yeah, we actually saw some improvement on the browser, obviously, but we also have another tools like Grafana, and I don't remember the other name of the other tool, where we actually saw the latency improvement when we migrated to between cloud providers.
Got it. So you basically have observability on the latency, right? And you look at your visual analytics when you deploy the new code,
Yeah,
and go from there, right?
yeah. We also have like a test, like basic test. So we make sure we still show the results in the order we expect. So in case, in case we put weight, we put page views, we still want to see the same order of queries.
Mm-hmm. So you're on spinning disk is what you're telling me?
What was that last part?
Is the class, no, are the nodes on spinning disks?
Oh, again, that might be an infra question.
Yeah, sorry. I'll hold off.
Yeah.
Thank you.
You mentioned using Grafana. Did you hear about the new announcement that Elastic is partnering with Grafana on an official Elasticsearch plugin for it? So, and I'm reading the tweet, it says it combines the benefits of Grafana's visualization platform with the full capabilities of Elasticsearch. I wonder if that's something that you'll be utilizing in the future. It's kind of a new,
Probably, yeah.
Yeah, it's kind of a new thing to add there of, being able to, and I want to also say that that's kind of, it's interesting that you mentioned like having your page views inside of your results, already stored. So like that information's already available. Whoever had the forethought to, let's just do that because that could be beneficial. Yeah, they deserve a pay raise. I'm hoping that was you, right?
No, we actually don't store the page views inside the Elasticsearch, but in another database, because we also provide something like analytics for traffic analytics. So we're using the data to feed into Elasticsearch.
That makes sense. And you might be able to even visualize all of that through like one of the beats that's provided to make it a little bit easier to ingest, or even Logstash. You, I guess, move everything together, but that's another meetup for another time. I'm more interested now as a Read the Docs user. I was actually using Read the Docs and then Make Docs, and then when I heard that Sphinx got to play with Elasticsearch, but at the time Make Docs didn't, I switched over. So now I feel like I jumped the gun a little too soon. But all in all, thank you so much for a great presentation and a very insightful one. I think it doesn't fall on a lot of people that, we talk about how important documentation is, but also making documentation accessible and like searchable is a huge benefit, in any way that we can support that. I'm sure that we'll want to as much as we can.